And welcome to Chapter 2, Matter and Change. Hey, this is the first chapter where we're going to actually get into some of the content of the course, and the title, Matter and Change, is very appropriate because that's what chemistry is. Chemistry is the study of the properties of matters and the changes that matter undergoes. So we're going to actually start diving into how we describe matter. We're going to talk about the differences between the various types of properties. We'll be talking about the differences between elements and compounds and mixtures and substances. And then we're also going to show you how to separate these things, either by using physical means or chemical means. So let's go ahead and jump in. We are now in 2.1, properties of matters, or properties of matter. And the first two types of properties that we want to talk about are extensive and intensive properties. Now, an extensive property is simply a property that depends on the amount of matter in the sample. If you notice, we are now in blue ink instead of red, just to spice it up a little bit. So what do we mean by a property that depends on the amount of matter in the sample? Well, an example of an extensive property is mass. If you say, how much does a particular sample weigh? Well, that depends. It depends on how big the sample is. Volume is another example. What volume does a particular sample occupy? Say some water. Well, it depends. Do you have a glass of water? Do you have a pitcher? Do you have Lake Erie? The property depends on how much you have. As opposed to an intensive property, and we'll go ahead and scroll down a little bit here. An intensive property depends on the type of matter. Depends on the type of matter. Some people say it depends on the identity. For example, something like a boiling point. The boiling point is the temperature at which a substance boils. So if you ask, what temperature does water boil? Water boils at 100 degrees Celsius. Doesn't matter how much you have. If you have a glass of water, pitcher, Lake Erie, water is going to boil at 100 degrees Celsius. It only depends on the identity, the fact that it is water. Now, in Chapter 13, for those who do that chapter, you'll see why water boils at 100 degrees Celsius and what are some of the things that contribute to that particular property. But it is simply a function of the type of matter or its identity. The freezing point or the melting point, which happens to be the same thing, is also an intensive property. Electrical conductivity. Does something conduct electricity? Well, it depends. Is it a metal? So we'll put that on there. Conductivity. So those are two different types of matter, properties of matter, extensive and intensive properties. Now let's move on to identifying substances. Well, first of all, as we scroll down here, what's a substance? Well, a substance is something that has a uniform and definite composition. Now, what do we mean by uniform and a definite composition? Well, let's just say, for example, we have a glass of water. So here's our glass. I'm sure everybody knows that water has a composition or a formula of H2O. And if you have a glass of pure water, it is exactly H2O, and it's H2O everywhere. It does not change. Okay, as opposed to, say, a glass of wine, and I guess we'll try to put a glass of wine next to this thing. or let's say milk. We're in a glass here. We don't have it in a wine glass, so we'll say a glass of milk. Now, milk is made up of water, and it has different fats in it, and it has lactic acid in it. I'll just put acid in there, and a bunch of other things. But the composition of this differs depending on the type of milk that you have. You could have 2% milk. We'll call it this. Here's water. We'll say this is milk. You could have, say, 2% milk. You could have 0.5%. You could have skim. There's cow's milk, goat's milk. There's different types of milk. But water is the same regardless of what it is, if you're talking about pure water. All right? So water is, in fact, a substance. It is the same throughout, and it is always the same, H2O. Now, milk, which we'll learn later on, is what we call a mixture. And so we'll leave that for later on in this chapter. Okay? Now, secondly, in terms of identifying a substance, one way that we can identify a substance is by using a physical property. Now, a physical property is a quality that can be observed or measured without, and this is a little symbol for without changing the composition. Composition. There we go. Now, some examples. I don't have an example box. We're going to write it off to the side. Let's go back to melting point or boiling point. The boiling point is a property that you can observe without changing what it is. If I have a glass of water, again, so here's my glass of water. If this thing starts to bubble and boil, okay, and it comes off as steam, like so, in the glass is water, H2O. We call it water, but it's H2O. Up here we have steam, but it is also H2O. Going from liquid water to gaseous steam does not change the actual identity or composition. It changes what it looks like, but it does not change the identity. That is an example of a physical property. If we scroll down, oops, let's see here, there we go. Jump down on us, but if we look down at table 2.1, this comes out of our textbook, you see a bunch of different physical properties of various substances. Again, here's water that we've been working with. Water is going to boil at 100 degrees Celsius. It is going to freeze or melt at 0 degrees Celsius. And it only depends on the fact that it is water, and you can watch those things and measure those things without changing what it is. Similarly, you can look at its physical state. You can identify it as a solid, liquid, or gas without changing what it is. You can observe the color without changing what it is. These are all physical properties. All right? In the next podcast, we're going to be looking at states of matter. It's an introduction to states of matter that will be further explained in Chapter 13.